All right, good morning, everyone. Today we're going to take a look at inequalities and solving inequalities. And finally, after everything I've told you about chapter 1 being so miserable, difficult, long, and just stuffed full of information, we have somewhat of an easier day today. I hope you'll agree. Inequalities are relatively easy to solve. And especially if you use a technique that I'm going to show you today, which I think is the easiest way to do them. So let's get started. An inequality is simply a math sentence with one of those four signs: a less than, a greater than, a less than or equal to, or a greater than or equal to sign. Not to insult your intelligence or anything. Some people get these signs mixed up. There's a couple different ways you can think about which sign is which, and that is, one is, this looks like a capital L, and L is the first letter in the word less than. That's one way to think about it. Somebody once told me that it looks like a mouth. A big mouth eats the big number. So the big mouth here eats the big number, the big mouth here eats the number on the left, and so on. So there's a variety of ways that you can remember how it's read less than or greater than, and hopefully you won't have any trouble with that. All right, so let's get started. Inequalities. You're simply trying to solve an inequality. You know that you're going to end up with something like x is less than something, okay? Or x is greater than something if the x ends up over on the right-hand side. You know you're going to end up shading one side, either greater than, you're going to shade up, or less than, you're going to shade down, okay? So what is of extreme importance is to find the boundary point. Okay, find the boundary point. So in other words, in a sense, I'm not even going to worry about the less than sign, okay, for now. But here we go. So let's do it. We have 6x is less than 9x plus 5. A couple different ways you can do it. You've got x's on both sides. We've talked about this before. You can try to keep the x term positive if you like. If you want to do that, you're going to subtract 6x from both sides. Well, over in this side, there's a 0 is less than 3x plus 5. Okay? Then, to solve now for x, you have to subtract 5 and divide by 3. And when you read this properly, now read it properly, x is bigger than negative 5/3. Okay? X is bigger than negative 5/3. So when you're going to tell me the answer to this problem, here is negative 5/3. Strictly bigger is an open circle, and you want to shade all the points to the right. And what we did was we found the boundary point. Negative 5/3 is the boundary point. Then we figure out which side to shade. Okay? Let's look at the second one. Second one is 5 minus 2x less than or equal to 7. I'm going to subtract 5 from both sides. Negative 2x less than or equal to 2. I'm going to divide by negative 2. Do you remember inequalities? When you divide or multiply by a negative, you have to flip that sign around. Okay? It has nothing to do with adding or subtracting. Okay? It's when you divide or multiply by a negative. For instance, forget this problem. We know that 3 is bigger than negative 2. Okay? 3 is bigger than negative 2, right? If I divide both sides by a negative 1, if I divide or multiply by a negative 1, I don't care. You're going to get negative 3 and positive 2. And the only way that can be true is if you flip that sign around. Okay, so multiplying or dividing by a negative, you got to flip the sign around, and I get x is bigger than or equal to negative 1. We have found the boundary point. Here's negative 1. This is a solid point. I'm bigger. I want to shade to the right. Anything that you pick to the right of negative 1 should work. Like 0 is to the right. Put 0 here, kills that term. 5 is less than or equal to 7. Okay? It's got to work. Put 100 in. 100 times 2 is 200. 5 minus 200 is negative 195 is less than or equal to 7. Okay? How about the last one over here? 4 less than or equal to 2x minus 1 less than 9. What's kind of cool about this problem, you know you want to get x by itself, you've got to get rid of the minus 1 and the 2. It's just that there's 3 parts instead of 2. So if you're going to add 1, you have to add 1 all 3 places, and you get 5 less than or equal to 2x less than 10. Yeah? Now we got to divide by 2. Okay, so divide everywhere by 2. I get 2.5 less than or equal to x less than 5. So I know in this one, I want x's that are in between 2.5. Here's 2.5. Here's 5. In between, solid point on the 2.5, open point on the 5, and I'm strictly in between. Okay? But notice what we did. We first found the boundary points. If you can find the boundary points, then all you have to do is figure out which side to shake. All right. That was just a warm-up. Now the fun stuff starts. Inequalities and absolute values. Oh, yes. All right, so here we go. If you remember to simply find the boundary points, these problems are incredibly easy. Now, there's a little bit of story to go along with this. Back many, many years ago, when I was finishing up my bachelor's work in mathematics, I got an offer to teach. I was going to be finishing up in December. I got an offer to teach at a high school down in Newark, Delaware. And I went down, made arrangements for an apartment and whatnot, yada, yada, yada. And the week before I was to go down and start teaching, I called the guy who had the position and was leaving it to become a guidance counselor. And I said to him, I said, what are you working right now? Mostly what I was teaching was an algebra class. I said, what are you working right now in algebra? He said, we are doing quadratics and absolute value inequalities. Okay, I got off the phone. I sat down and I thought, how in the world am I ever going to show this to students? Here I was, having just taken some of the hardest math courses possible. Okay? And I actually had no way of showing anybody how to do a problem like that. And I shudder to think, now that I look back on it, the way that I showed them. It was horrendous. It worked, but it was horrendous and very, very difficult. Many years later, it's much more easy to do these problems if you concentrate on what I said on those first 3. Can you find the boundary points? So for this problem, x squared is less than x plus 12. Do the boundary points. Do it when x squared is equal to x plus 12. Okay? That'll give us just the boundary points. Then we can figure out which side to shake. All right? So let's do it. We know how to solve this. It's a quadratic equation. There's nothing in front of the x squared. It's going to be an easy one. Yes? Get everything on one side. Subtract x, subtract 12. Can you factor? Sure. Easy to factor. X and x, because there's nothing in front of the x squared. I need factors of 12 that subtract to give me 1. Factors of 12 subtract to give you 1 are 4 and 3. How about the signs? To get a negative 12, you got to have either a negative and a positive or a positive and a negative. And the trick is look at this sign and put it with a bigger one. The inners are bigger than the outers, so negative, positive. Set each part equal to 0, and you're going to get 4 and negative 3. Yes? Those are the boundary points. Those are the boundary points. Here's negative 3. Here's 4. Because it is strictly less than, I know they will be open. Yeah? Pick a point. 0. 0 less than 0 plus 12. It is. So I know this is shaded. You can keep going if you like. Negative 5 25 is less than 7? I don't think so. Positive 5. 25 is less than 17? I don't think so. Just that region in there from -3 to 4. You can check any point at all in there if you want to see if it works. How about 2? 4 is less than 14. Sure, checks perfectly. This is the absolute easy way to do all of these problems. With an inequality, find the boundary point and then figure out which side to shade. Okay, how about the next one? X squared less than or equal to 16. Do the boundary points. X squared equals 16. And remember what we talked about on quadratics? When you have no x term, you can use square roots. So don't you instantly know that x could be 4 or -4? And because it's less than or equal to, these are solid points. Pick a point. How about 0? 0 squared is less than or equal to 16. It is. We should be in here. You can try the other ones. 5 squared, less than 16. I don't think so. -5, nope. It's just that region there. Okay? Look at the one on the far right over there. X plus 3 squared, x plus 1. Find the boundary points. Make it equals. Okay? It's already factored for you. What more do you want? This times itself times this is 0. I have 3 things multiplying equaling 0. Yes? 3 things. This one, and that one. Okay? 3 things. So you know that one of them has to be 0. You can set all 3 of those equal to 0. You're going to get -3, -3, and -1. So I'm just going to write -3 or -1. Boundary points. Here's -1. Here's -3. Because it is strictly greater, I'll put open circles. Okay? Let's pick a point. How about -2 in the middle? -2. Now you got to be careful here. -2 plus 3 is 1. 1 squared is 1. -2 plus 1 is -1 times 1 is a negative number. That's not true. Okay, so we don't shade in the middle. How about to the right of -1? How about 0? That's going to make this just 3 and 1. 3 squared is 9. 9 times 1, bigger than 0. Yeah, so this side works. How about down here? Like -5. -5 plus 3. And actually a slightly easier way to do this. -5 plus 3 is negative. Squared is positive. -5 plus 1 is negative. A negative times a positive is a negative, and a negative, I'll be damned. Let's try that again. I'm having a senior moment here. -1 and -3, and -5 plus 3 is negative, squared is positive, times a negative, and it doesn't work. The only thing that works are numbers up there. Okay, pick another number just for fun, just to see if it works. How about 10? 13 squared is a positive number. 10 plus 1, positive number. 2 positives make a positive bigger than 0. Okay? Okay, so more problems now. Let's go with absolute values. Okay? Quickie absolute value problem, just to refresh your memory. Suppose you have the absolute value of x is equal to 7. If you recall, the absolute value is how far a number is from 0. Okay, 0 is here in the middle. How far, if the distance is 7 from 0, we could be over here at +7 or back here at -7. So we know that x could equal 7 or -7. So let's go to this problem. Absolute of 3x. We're going to look for the boundary points. Look for the boundary points. If an absolute value is 15, I know the distance from 0 is 15. Okay, so it could be 15 to the right or 15 to the left. I know that's what's under my hand. What I'm taking the absolute value of could be 15 or -15. So 3x could equal 15 or 3x could equal negative 15. And solve. X is 5 or negative 5. All right? Number line, negative 5, 5. Okay? I want less than. Figure out where to shade. Try a point. How about 0? 0 in here makes 0. That's smaller than 15. So I shade in here. It's strictly less than, open circles. Try something to the right. How about 6? 18, absolute value is 18. Doesn't work. Negative 6, negative 18, absolute value is 18. Still doesn't work. That is your only answer. Okay? You see, this technique of finding your boundary points works beautifully. Let's go to the next one. Absolute value of x plus 1 is bigger than or equal to 1. Hide it and go for your boundary points where it's equal to 1. If something has an absolute value equal to 1, it could be either 1 above or 1 below 0. So I know what's under my hand. X plus 1 could equal 1, or x plus 1 could equal negative 1. Subtract, I get 0. Subtract, I get negative 2. Those, folks, are your boundary points. Here's negative 2. Here's 0. Because it's greater than or equal to, I know these are solid points. Pick a point. How about in the middle here? Negative 1. If you put negative 1 in here, negative 1 plus 1 is 0. Absolute value is 0. Is that bigger than or equal to 1? No way. So you don't shade in the middle. I'm guessing we're going to shade on either side. Now you have to be careful about that. Most absolute value problems will either be in the middle or on either side. What you got to be really careful about, like this one was not in the middle or on either side. Okay? But most absolute values in quadratics will be in the middle or on either side. You just have to watch out. And if you don't trust yourself, just always try points on either side. Like 1. 1 plus 1, 2. Absolute value 2. Yeah, bigger than 1. Try 1 on the left. Negative 3. Negative 3 plus 1. Negative 2. Absolute value 2. Bigger than 1. So it checks right there. Next one. Absolute value of 8x plus 3 less than or equal to negative 5. You should not do any work in this problem because absolute values are always what? Aren't they positive or 0? How could an absolute value be smaller than a negative number? It would have to be negative. That's ridiculous. Okay? No answer to this problem. Next one, absolute value, 2x minus 5 less than 8. Let's go for the boundary points. What's under my hand, if it has an absolute value of 8, could be 8 above, could be 8 below. What's under my hand, the 2x minus 5, could equal 8, or 2x minus 5, negative 8. Add 5 is 3. Or 13, pardon me, divide by 2 is 6.5. Add 5 is negative 3. Divide by 2 is negative 3/2 or negative 1.5. So let's do a graph. I am here at negative 1.5. I'm over here at 6.5. Because it is strictly less than, I want open circles there. Okay? Pick a point. How about 0 in the middle? 0 times 2 is 0 minus 5 is negative 5. Absolute value of negative 5 is 5, and that is indeed smaller than 8. I'm saying it's in the middle. Try a bigger number just for fun. 10. 20 minus 5 is 15. Absolute value is 15. No way. Doesn't work. Try a number down here on this side. How about negative 10? Negative 20 minus 5 is negative 25. Absolute value is 25. Doesn't work. Okay? Only answer is in between. Okay, last one. I told you today was an easy day. X squared minus x less than or equal to 5. We're gonna go for the boundary points. The boundary points, x squared minus x equals 5. It's a quadratic. X squared minus x minus 5, get everything on one side. And guess what? Can you find factors of 5 and subtract to give you 1? No, you cannot. So we're going to have to solve this, to find the boundary points, we're going to have to use a quadratic formula. Quadratic formula is the opposite of b, 1, plus or minus the square root. B squared is 1 minus 4 times a, 1 times c, negative 5. All over twice a is 2. My marker is losing it. Negative 4 times negative 5 is 20, plus 1 is 21. So this is the square root of 21. So let's get some answers. I want the square root of 21, which is 4.58. Okay, 1 plus 4.58. So 4.58 plus 1 equals, divided by 2, equals 2.79. My marker is quickly dying. 1 minus 4.58 equals, divided by 2, equals negative 1.79. Those are your boundary points. So I have negative 1.79 and I have 2.79. Because it is less than or equal to, hopefully you agree with me, solid points. Pick a value. How about in the middle? 0. 0 squared minus 0 is indeed less than or equal to 5. I think we're good with that answer, but just to be sure, let's check. A number bigger, how about 10? 100 minus 10 is 90, less than 5? I don't think so. How about negative 10? 100 plus 10, 110, no way. So those are, the shaded region would be your answer for that particular problem. Here is the homework. Take note, there is a couple of extra problems. We're getting toward the end of this chapter, and I wanted to remind you of some of the things we've been doing thus far.